Hi, my name is John Anzola, lecturer and researcher in Mondragon, Universitatea, and today in this short video I will present you the work we presented in the ECCE Europe 2025 entitled Experimental Validation of a Modular Transformer for Multipurpose Series and Parallel Configurations. On this slide, you can see the outline of the presentation. First, I will introduce the motivation and the idea behind using a modular transformer instead of a single unit. Then I'll show the experimental results for the three different test conditions that we made. And finally, I'll summarize the main conclusions and takeaways. So, to improve the flexibility and scalability of power converters, this work explores a modular transformer integrated into a dual active bridge or DAB topology. In a DAB converter, the high-frequency transformer is a key component and it strongly impacts performance and scalability. Here we compare two approaches, a single transformer versus a modular transformer. The modular approach enables configurable series and/or parallel connections of both primary and secondary windings. This allows the transformer to operate under varying voltage conditions while maintaining consistent power transfer. At the bottom, you can see the pictures of both prototypes, and on the right, we summarize the main electrical parameters we characterized, mainly the leakage inductance and the magnetizing inductance, in order to understand how similar they are before running the experimental test. The study compares a conventional single transformer with a modular transformer under three test scenarios. Test number 1 at 400 volts with series configuration. Test 2 at 200 volts with parallel configuration. And finally, test 3 at 400 volts, 200 volts with series parallel configuration. Key challenges addressed include power sharing imbalances and inductance mismatches due to assembly asymmetries. The aim is to validate the modular concept experimentally and assess its performance benefits in real conditions. Below, you can see the prototype and the main elements of the setup. The primary and secondary sides, the transformer section, the power supply, and the DSP controller. Here, in test 1, both solutions performed similarly, with the single unit transferring 10.62 kilowatts versus 9.77 kilowatts for the modular. This power difference is strictly related to the different leakage inductance values presented before. In the case of the single transformer, it's 42.3 microhenries, whereas in the modular transformer is 46.77. The figures show the experimental waveforms of the single and modular transformer at test 1. In the left, the primary and secondary side AC voltages and the primary side current are shown. In the right, the same parameters are shown, but considering that due to the series connection of the AC voltages are shared between each module. When it comes to the AC voltages of the modular transformer, a non-equal voltage distribution is observed, especially during the period where the primary side current is flat. It must be then provoked by the magnetizing current of the transformer and the different magnetizing inductance values. However, the voltage difference measured at the end of the positive period is around 80 volts, which is 20% of the total 400 volts. On the other hand, the magnetizing inductance difference between each modular transformer is 217 microhenries, which is only a 9.36% of the total magnetizing inductance. This discrepancy between the difference in magnetizing inductance and unequal voltage distribution may be due to the handling of the cores during manufacturing. Such manipulation can alter the values, leading to discrepancies in the measured voltage. In test point 2, the modular transformer maintains 9.47 kilowatts, while the single transformer could only achieve 2.6 kilowatts. Therefore, the power achieved by the modular transformer is 3.6 times higher than the single transformer. This is achieved by manually placing in parallel the primary and secondary side ports of the modular transformers. This way, the equivalent inductance of the modular transformer is also nearly 3.6 times lower than the single transformer leakage inductance. In order to achieve a similar leakage inductance with a single transformer, a new transformer should be manufactured. The experimental waveforms of the single and modular transformer at test 2 are shown in the figures below. In the left, the primary and secondary side AC voltages and the primary side current are shown as previously, and in figure 6, in the right figure, same parameters are shown, but considering that due to the parallel connection of the AC currents are shared between each module. Compared to test 1, the single transformer is only capable of transferring half current with the same phase shift. However, due to the parallel connection, the modular transformer is capable of maintaining the same current through each module. In this case, the current through each module is equally distributed, without any imbalance as shown in the previous tests with the voltages. In test 3, the modular solution nearly doubled the power of the single unit. This is explained with the transformation ratio. In the case of the single transformer, this value is 1, while in the modular transformer is 2. Also, in the figures below, we can observe that on the right, in the modular transformer, the AC primary side voltages and secondary side currents are shown. These are the parameters that are shared between each module due to the series parallel connection. Observing the results, the single transformer in the left, we can see that it's close to provoke hard switching in the primary side semiconductors. Meanwhile, the current waveform in the modular transformer is perfectly trapezoidal, far from presenting hard switching conditions. Finally, here are the main conclusions. Among the tested configurations, the series connection proved to be the most sensitive, showing an equal voltage distribution between modules due to the differences in magnetizing inductance. A 9% variation in the magnetizing inductance could be translated into a 20% of voltage imbalance. While this did not degrade performance at the tested power levels, it may pose limitations in higher power applications. In contrast, the parallel and series parallel configurations showed uniform current and voltage behavior, confirming the robustness of the modular solution under varied operating conditions. Alright, so that's all from my side. Thank you very much for watching. If you have any questions or would like to discuss the work in more detail, please feel free to reach out to me by the contact email shown here, and that's all. Bye bye.